Hello everyone, I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture, I'll be introducing some of the most important security features in 5G networks. With 5G, we are stepping into a new era of connectivity that goes beyond just faster speeds. It's about connecting more devices, supporting critical applications, and enabling new services like autonomous driving, smart cities, and massive IoT networks. But with this expanded reach, 5G also brings unique security challenges that required equally advanced protections. As we move forward, securing 5G means addressing risks that range from protecting user data to preventing network attacks that could disrupt essential services. In response, 5G has been designed with robust security features from the start. These features include network slicing isolation, which ensures separate virtual networks on a shared infrastructure, enhanced encryption that protects data during transmission, and identity protection methods that keep user identities safe. Additionally, 5G authentication and key management provide strong verification to ensure that only trusted devices access the network. And the network function virtualization security protects the software defined components of the network itself. So this proactive approach to security means that we can make 5G not only a powerful technology but also a trusted one. So let's dive into these security features and see how they are working to make the 5G ecosystem safe, reliable, and resilient. First, security features in 5G. 5G network incorporate a suite of advanced security features designed to protect the integrity and privacy of data while addressing the unique challenges of a multi-layered high-capacity environment. Key features include network slicing isolation, which enables the creation of isolated secure virtual networks, preventing cross-slice data interference. Enhanced encryption protocols such as AES are used to protect data as it moves across the network, while authentication and key management mechanisms ensure that only verified devices can access the network. Next, user and device identity protocol leverages SIM authentication and certificates to shield user identities, adding another layer of security. Additionally, network function virtualization (NFV) security is applied to secure virtualized functions and maintain network integrity, while security by design ensures these protective measures are integrated from the outset of network development. Next, network slicing and isolation. This we have seen many times. Network slicing is a pivotal feature in 5G networks, allowing for virtual isolated network segments within a shared physical infrastructure. This segmentation enables different types of services, example IoT, autonomous driving, or mobile broadband, to run or their own dedicated network slices. From a security perspective, this isolation provides critical advantages. It prevents data interference between slices, ensuring that the data in one slice remains secure even if another slice is compromised. Furthermore, it isolates threads within individual slices, reducing the risk of cross slice attacks and improving overall resilience of the 5G network. Next, encryption and authentication. 5G network employed enhanced encryption to protect data against no, interception using advanced encryption standards like AES to secure communication across network layers. This means that even if data is intercepted, it remains unreadable without the decryption key. Authentication and key management processes verify both device and user identities before granting access to the network, providing an additional layer of trust. Secure key exchange protocols further ensure that only authorized devices and user can participate in network communication, safeguarding against unauthorized access and enhancing overall network security. Next, identity protection and secure device onboarding. User and device identity protection. How we are going to protect it? SIM authentication and certificates prevent unauthorized access, and it protects user from identity theft. Next, security device onboarding. Devices securely onboarded through SIM card authentication and secure provisioning. Now what we are doing, we are inserting the SIM in the new device. Ensure devices meet uh, security standards before network access. Next, security challenges in 5G system. Despite these advances, 5G networks face several security challenges. User equipment threats include mobile malware such as viruses, worms, and trojans, which can compromise devices and potentially disrupt network operations. Applications from untrusted sources pose a significant risk as they can introduce malware or serve as a vector for DOS attacks. Meanwhile, access network vulnerabilities are an ongoing concern as hybrid 2G, 3G, 4G networks introduce legacy security issues. This can lead to attacks like location tracking, message interception, and unauthorized buffer status reporting, which could compromise user privacy and network performance. Next, 5G network functions and interface security. Network function virtualization, that is NFV, security in 5G networks secure software defined network components against vulnerabilities and exploits that could arise within virtualized environment. This protects the integrity of network functions that operate virtually, ensuring continuity and reliability. Radio interface security safeguards the wireless communication channel, preventing eavesdropping and other radio based attacks. By securing the radio interface, 5G networks ensure both the confidentiality and the integrity of transmitted data, which is essential in wireless environment where data is particularly vulnerable to interception. Next, future security threats and mitigation in 5G. Looking ahead, future security threats in 5G will include new attack vectors created by the proliferation of IoT devices and vehicle to infrastructure V2I communication. The massive scale of connected devices increase the risk of distributed denial of service, that is DDoS, attacks on the radio access network RAN, which could potentially overload the network. Additionally, mission critical services like robotic surgeries will require comprehensive protection from zero-day exploits to prevent life-threatening outcomes. Mitigation strategies include securing multi-access edge computing (MAC) and small cell deployments, as well as implementing continuous monitoring and real-time auditing to detect and respond to threats promptly, ensuring resiliences in the face of emerging security challenges. So this is about future security threat and mitigation in 5G. Next, coming into the conclusion. In conclusion, 5G networks incorporate advanced security in future to address the unique challenges of this highly connected data driven ecosystem. With protections like network slicing, isolated isolation, enhanced encryption, and user identity safeguards. 5G is designed to mitigate risks that come with expanded connectivity and critical applications. Strong authentication and key management measures ensures that only trusted devices and users can access the network, reinforcing the overall security structure. Together, these features establish a secure, reliable foundation for 5G, enabling the technology to support a wide range of innovations while protecting data, devices, and user against evolving threats. Thank you for joining this session on the 5G security features. Hope everyone enjoyed this lecture. The remaining things we'll discuss in the next lecture. Thank you.